Hello, everybody. Welcome to today's webinar. We're going to be talking about RoadEng for resource roads. And this is kind of a catch-all introductory seminar for any type of resource road, access road, haul road, forestry road, wind farm road. We're going to give you just the fundamentals for that rural road design using RoadEng. We're going to go through sort of the key workflow for you new users and for people who are looking for a bit of a refresher. So we'll start with some terrain data, move through to creating alignments, output sheets, that kind of fun stuff. If you are new to our webinars, welcome. My name is Erin. I'm the operations director here at Softree. And with me today is our training manager and our resident webinar host, or presenter, Matthew Dickey. He's going to be taking on the lion's share of today's presentation, taking you into the software and giving you that introduction. A bit of housekeeping before we get started. First and foremost, you are all going to be muted and you're going to stay muted for the entire presentation. But we'd love for you to engage with us. And there's two different ways you can do that. If you're here in the live webinar, please just open up that question section. You can type anything at any time during the webinar. We're happy to address those questions at the end. And if you're watching this in the future off of our YouTube channel, feel free to type a question in the comment section below. We're happy to answer those too. Okay, to get started, obviously, access roads are a pretty essential piece of infrastructure, and really their location and their construction have very significant impacts on your project's efficiency, operational costs, and even on the environmental impact of the road itself that's being designed. So we know that they're important. And so today we're going to really show you how you can use RoadEng first and foremost to determine sort of some optimized locations that you could put that new access road in, help you convert an initial alignment, or that initial preliminary alignment, I should say, into a full detailed geometric design where you can start to consider some of those environmental impact items, such as the hydrology and the road's interaction with it and the terrain. We'll show you how to reduce your earthworks and your construction costs, and a lot of that comes through minimizing how much you're cutting and filling. So we're going to tackle that. And then finally, we'll show you what to do with it, whether you were exporting to another software or just looking to create some paper documentation to represent your road. So that's kind of our plan on a page for today. We are going to be leveraging RoadEng Civil Engineer or RoadEng Forest Engineer software. To be honest, they're two slightly different variants of the exact same software, and it really just comes down to what defaults you have installed. But with RoadEng, both versions, we do have two modules, and the module is really a mini program that runs as a part of the big program. So it's two modules, and we're going to start in the terrain module. That's where we've got our ability to create a terrain surface and do something called path exploration, and then our location module, and that's our detailed corridor design module. So if you see us change programs during the webinar, that's why we are modular. And that first module, as I mentioned, is the terrain module. So here, this is where we're going to import our topo data. And your topo data could be LiDAR, it could be UAV data, it could be total station data. Basically, any type of way you're going to represent that original ground. We're going to bring it in. DEM is another example, I guess. We're going to bring it in, and then we're going to create something called a TIN model. And that's a triangular irregular network. That's our surface model that's going to represent our data. From there, we can add a bunch of constraints, discover where our likely location of streams and ponds are, a bunch of other elements we can do. And then our big step here to sort of finalize terrain is to really figure out an initial alignment. And I don't know if you can see, it's very small in the picture, but there are two little black triangles coming off the surface. That's where we're going to try and figure out where to put a road today. So we're going to go from one point to the other point to get into this resource site. Again, pick your choice if you want to imagine this is mining, is it forestry, your choice. Any type of resource access road, we're going in this fun terrain. And then once we figured out that initial alignment, we've built our TIN surface, we're going to save this. And our native format inside of RoadEng is called a TERX file. So we're going to save that, and then we're going to head over into our second module. This is our location module where we actually do the full corridor design. So some key steps you're going to see in today's webinar. We're going to start by going and opening a new location design, referencing that topo file that we just made. We're going to set up our typical cross-section. RoadEng has a wide variety of cross-section templates and template components that you can pick and choose from to make your ideal cross-section. I'm going to say probably the most complicated part of our software. And if you ever have any questions on this, do not hesitate to reach out to our support team. They're pretty easy for us to answer. Next, we're going to create our horizontal and vertical alignments. There's a whole bunch of tools that can really help with the automation of this process. So we're going to talk through that. We're also going to demonstrate if you want to make manual edits, what that looks like as well. So it's not just an automatic process from start to finish where you just click buttons. There is obviously a full manual side of RoadEng as well. Following the horizontal and vertical alignment creation, we're going to spend a little bit of time talking about mass haul balancing, and of course, the key piece that helps us do that, vertical optimization. So vertical optimization is this fantastic mathematical tool that allows us to minimize our cuts and fills along our alignment, figure out where materials need to come from, where they need to go to, and solves that entire conveyor belt problem. So a really exciting tool that can help simplify and greatly reduce the earthwork costs of your project. From there, we've got, a little button that wasn't advancing, culverts and different details. So we are going to be able to add culverts, look at other alignment details, adding those into the project. And then finally, we'll talk a little bit about different outputs, whether that's multiplot as shown here on the screen, or the output that decided to not show because it's missing. Yeah, with that, Matt, I'm going to pass you the screen
Alrighty,
because
I'll
my
dive in. I'll share my screen here.
perfect. I'm going to make you the
And
presenter.
all right, so as promised, we're going to start out in terrain, and then we're going to just build up our project, kind of start from scratch, work through each step, and provide a little bit of explanation for each step as we do it. So, as introduced, the software is modular. So we're going to start in the terrain module just by double-clicking the little icon with hills. And, well, in order to design this project that we're going to design, we need to have some frame of reference for what the ground is doing on the site. So we need some topographic data. So for that, we'll click Insert. We're going to go to wherever our data is saved, and we work with a wide variety of data types here, but some common ones being TIFF for DEM data or DTM data, and LAS data would be another common one for these larger LiDAR sites. I'm going to just bring that in. Now, this being a TIFF, it can be either a image or a raster. So we are going to select that we want to bring this data in as a raster. And, well, then we get a few options. So we could thin our data on import. Now, I'm not going to. That would help us deal with really large data sets. I'm going to do it after the fact. We have the projection that we're working with, well, read in with the TIFF. So we don't have to worry about doing transformations, but if we wanted to do one, we could. But yeah, usually we can just run with those defaults, hit OK, and away we go. Now I'm going to just scroll out a little bit here for a little bit of a frame of reference. So we can see that big magenta blob. Well, that big magenta blob is our topo data. And if we zoom in just a little bit here, we can see that that big magenta blob is actually, well, in this case, 16 million points. And those points are not being displayed. So they're being shown right now because they are selected. And when we bring the data in, it is selected. But we can deselect them by clicking off to the side, and we still have those 16 million points in there. Just because they're not being shown doesn't mean they've disappeared. Now, I briefly mentioned thinning our data down on import using that selection tab. We also have thinning tools afterwards. So if we brought it in and we realized, well, 16 million points is pretty heavy, let's reduce that. We could use the simplify option here, or I really like it with DEM data using the feature simplification here. So I'm going to run it. It's pretty quick for what it does. And voila, we've gone from 16 million points down to, well, just shy of 4 million points, but we've kept a really good level of detail in our surface. And to take those 4 million points and turn it into a surface, we've clicked terrain modeling, generate, and well, we'll create our tin. So we do need that tin surface. That's a minimum requirement. But optionally, we can create contours too at the same time. So I have both major and minor contours being generated. My minors are 20-meter intervals and my majors are 100-meter intervals. So we're going to hit OK. The tin surface itself actually calculates very quickly. So the tin is already done, and we see that the contours take a little longer to calculate, but still very quick for what it's doing. So we have the first glimpse of what our topography is actually doing. But if we want to see that in a 3D surface, rather than looking at that bird's eye view we have here, we could click the little 3D icon in the bottom left, and that's going to activate our 3D view. And if we wanted to see both of those simultaneously, we could tile those views next to each other. And there we go. We can pan around, look at where we're at in the different views, and really get a sense of what we're up against. Now, at a bare minimum, we need that surface. We could start designing with just this, but we have some optional steps. So if we want to add a kind of a frame of reference for where things are at, well, we could bring in other data. I could come up here, I can click Insert File, and other than just the DEM data in this case, well, we can support kind of the industry standard formats. Here I'm going to bring in just a point that we can use as a frame of reference for where we want to start and where we want to end. So this is a shape file, could be a KML, could be a DWG, could be, well, we just draw on the lines or the points that we'd like to use ourselves. But in this case, we have it, and we'll come over here. Now to start, we have 2 points being brought in. It's probably pretty hard to see those on other people's screens. So I'm going to just change the symbology associated with those 2 features that we've inserted. So I want to make the dot for them, rather than just being a single pixel, we're going to go with a larger dot. That covers our plan view. But if we want to have something that we can see in the 3D nice and easily, we can click this 3D symbol dropdown. I'll make it a pyramid. Now to start, that pyramid is just going to be a 1 meter height, and that's going to look pretty small on this. So instead, we're going to scale this up, and we're going to say that it's actually scaled by a factor of 50, and we'll hit apply. So we can see we want to start down here, and we want to go up to there. Well, other than just having those points, we could continue bringing in other vector and point data if we had it. But images are often nice to use as well. And for that, we could go up to the home ribbon. We could click import, and we could bring something in from, well, the web map tile service. So we could go off Bing, Google, we could add in our own map sources if we like, and we could download. And I could say, well, I only want the data within this polygon here, and we could hit save. And it would take a few moments to download, and voila, we'd have it. Now, instead of downloading that, because it will take, well, it's a fairly large area, it'll take maybe 30 seconds, a minute. I'm going to cheat, and we can use something that we already have. So if we didn't have, well, if we had our own ortho imagery that we'd like to use, we could right click, we could click plan options, and we could add that in as a background. So here I'll click add. I have an image file saved here in a terrain. We'll add that in, we'll hit OK. And voila. So again, still just kind of adding context for things. Now, again, if we were designing manually, we could just run with that, jump over into location and figure out where to put the road to go from this point to that point. But we have a smarter, faster way to figure out how to go from that point A to point B, and that's Path Explorer. So up in the top ribbon here, we could click Optimization, we could click Path Explorer, and we could put in our design parameters and let the software figure out how to get there. And in doing so, the software would look at our earthworks costs. So it's using a simplified cross section going from point A to point B. It's going to wiggle around, trying to stay within our grades, adhering to that minimum curve spec. But aside from just dirt, there's going to be some other things that we want to consider here. And those other things could be, well, maybe there's a sensitive site where we're worried about terrain stability. So we could add in a polygon or draw in a polygon and say, well, I don't want to go there. The most common one is going to be accounting for where water is. So whether those are streams, ponds, etc., we probably will want to have at least some consideration for that, unless we were doing an entirely ridgetop road. So rather than just drawing in each streamline or inserting it from another source, we're going to use the hydrology tools. We've got those hydrology tools. We'll click streams and ponds. And well, here we can say, well, I want to create streams anytime there is a point on the surface that has a contributing drainage area greater than this value. So a drop of water would say land there, it would come down the hill. And if it got to say that point and it started to have a minimum drainage area greater than that, well, then we'd start to draw a little blue line. So we could hit OK, and we'll see what that spits out in terms of, well, streamlines and pond polygons. And well, we may decide that, well, that's pretty good, but my streams should start a little higher up in the watershed. Well, we could reduce that number that we were just looking at. So I'm going to roll this back to our default value, so 7,500 square meters. We'll hit OK. And we'll see by using a smaller number there, they extend further up the watershed and we get more streams. I think that's probably a more appropriate solution for this particular, well, region and topography. So now that we have those streams calculated, let's run from that start point to the end point. And here I will say I am using version 12. So the UI is a little bit different from version 11, but the concept's the same. So I'm going to come in here and I'm going to say, well, I want to keep a road width, and maybe we'll go with that 12-meter road width. We can set our minimum curve radius of, well, maybe we want to go with 50. We can set a max grade, and I'm going to go quite steep for this access road, so I'm going to go 16. I'll keep it kind of symmetrical, so it can go up or down at 16%. But for those of you kind of in the industrial settings, sometimes you'll want to have a different max grade for adverse hauls versus favorable hauls, and this supports that. And then we'll come over to the endpoints tab, and we'll say, well, I want that point and that point to be my start and end point. So we'll hit choose. Now I happen to know what those features are named, so we're going to select those. If we didn't know right away, we could just, well, click on the feature before we jumped in here, and we could see the name would be reported up here. But we want to go from that point to that point using the specs we've provided. And then lastly, well, we took the time to calculate where those streams are going to be. So let's add those streams in as a construction zone. And again, construction zones don't have to be any one thing. They could be, well, this is an archaeological site that I absolutely do not want to go into. So that could be a no-go polygon. It could be, I want to stay within this kind of permitted right-of-way, and that could be a no-go polyline where you're not allowed to cross that line to go to the outside of it. It could be polygons where this is going to be a shallow soil that's going to be more expensive to excavate at depth. So we could add in something where our excavation costs are more. And we'll go with these polyline features for our streams. And I'm going to just say each one of these is about $4,000 to cross. And if we had, well, a river that we wanted to have more expensive, we could do that as well. But I think we'll get a pretty good result just treating them all as the same. So we've got things set up. We'll hit OK. This is going to think, and it's not going to be instantaneous, but it is going to be very quick for what it's doing. And we'll hang tight for a minute, 2, maybe 3 on this example. But yeah, for what it's solving, it is extremely quick. And with that, we may have a moment for questions if anyone happens to have any questions so far for what we're tackling here.
We've got a quiet audience today, Matt.
We do. That's all right. We'll get into, it'll be more, yeah, the aha moment hasn't happened yet. So
We do have one question here, which is how do I revert or remove the hydrology that was just inserted?
oh,
It's a
I
great
like that
question.
question. Yeah. And while my screen's tied up here, I won't show it, but I will momentarily. One option, if we wanted to just run it with a different set of standards or a set of specs, we could. And actually, I'll just jump back into the stream stuff here for a moment. So when we're running this, if we decided we wanted to rerun it with, say 50,000 square meters here, when we have this remove existing features checkbox turned on, it's going to replace what was done the last time. If we wanted to undo something that we just did, we could, of course, hit the undo button up at the top or Control Z. And then, well, if we just wanted to hide them, we could come in here and we could say, well, I want to select all the stream features, and we could select them by layer or by name, or we could just highlight one and select what's similar. And we could turn off the display property. So kind of like our DEM points when we first brought them in. If we wanted to just not see something, but still have it in our model that we could refer to later, we could turn them off here. And then lastly, if you just decided that I didn't want to see those features at all, well, we could go terrain modeling and we could delete them. And without having to go find them in a list or anything like that, we could click delete, and then we could select that we want to delete our streams and ponds features. So lots of different options to remove them or go back to what we had. And hopefully that answers that question. And yeah, while we were answering that question, it did solve. So we have our solutions. And I'm going to just take a minute here rather than rushing over to the next step. We're going to talk about what these options are. So we can see when I ran this, one of the options that I told to run was give me 5 options. So of these 5 options, you'll notice that there's not anything that comes way over here and zigzags up a few times, gets on that ridge and gets that way. And that's not to say it's not possible to do something like that. These options that it's producing are all within 15% of the cheapest, but they're the most spatially diverse. So yeah, we can see in this particular example, all the options to really have things significantly different happen on the north side of our project. And well, if we're sanity checking it, it makes sense. With our grades the way we have them, we're able to get on top of that ridge, which is going to be by far the cheapest solution, gets to where we want to go. But down here, we have a lot more flexibility to move things around without having an increased cost for those alternatives. Now, of these alternatives, if we wanted to see which one of these kind of was expected to be cheapest, we can right click, select feature. If we select by name, we can see we've got all these Path Explorer solutions. So their naming convention is .xpath. And then the number, so we've got run 1, so they're all from run 1, and then option 1, 2, 3, 4, 5. And the number that comes after that 625.39K is the expected cost. So you can tell that that one's cheaper than the others. If we want to identify which one it is, we can select it here. And when features are selected, they'll be highlighted in magenta so we know what one's what. So it's nice to have options. If we were to do that and we said, well, I actually like the shape of that one better, we could of course run with it. We could take it to the next step for further evaluation. But in this case, we'll at least start with that 625 solution. So I'm going to hit save. I'm going to save this terrain file as well, topo, and we'll let it do its thing as it saves the actual file itself. And then we're going to switch over to the other module, which is the location module. And that's where we'll take this really smart line on the map and yeah, turn it into a proper design. So, location, again, we started in terrain. Now we're going over to location. We're going to click the little green icon. We're going to click new file. And we're going to click browse. And oops. We're going to see where I actually saved that file. All right, saved it somewhere other than where I meant to, but that's all good. So we'll come in here. So I'm going to just reference that terrain file that we've just saved. We'll hit OK. Now here, again, we could start from scratch, ignore all that good stuff that we did with Path Explorer, and we could just choose an initial alignment that was just a single point, and we could manually draw in where we'd like the road to go. But of course, we've taken the time to run Path Explorer, and it's going to do a better job than what we'd expect to do by hand anyway. So let's just run with that. So we'll hit OK here. We'll hit next. We'll hit done. And we'll have, well, things begin to take shape. So with this guy here, well, we can pan around. We can familiarize ourselves with what we're looking at. Now, we can see that the road that we're designing right now has an actual cross section associated with it, a 3D surface being calculated. Now, we had that ortho. So if we want to add the ortho, it was a different terrain file. We're going to add that into this guy here. So there's our background image. And well, we could note that this Path Explorer solution that we've got, it's a really smart line on the map, but it's a polyline. So if we want to take that and have proper curves and tangents assigned to things, well, we can do that. And we could do that manually again, but well, why would we if there's an easier way? So we can go over to operations, we can click polyline to alignment. I'm going to say, well, let's create a new alignment that adheres to our minimum radius and that max offset distance. I'll let it go. It's going to try and do as few curves as possible given the tolerances that we've provided. We could let it keep going, but I'm going to just hit cancel here because I'm happy with as close as it's gotten. And then, well, we're kind of set up. We've got a proper 3D alignment. We can see what we want to see in the plan view. We've got our topo surface that we can see with what we're interacting with. We could, of course, design and move things around manually and design our vertical alignment manually. But again, there's an easier way. So why would we? And well, that would be to run the vertical optimizer. Now this vertical optimizer, the way it works is it's going to look at the expected volumes along our road. If the road was at a different elevation, and we'd have our K values for our vertical curves being set, and it would try to minimize those costs. Now, as it's trying to minimize those costs, well, it's going to use the cross-section geometry. And obviously, a pretty important thing for having the geometry in the right spot, understanding what we're interacting with and how much dirt has to be moved is getting that cross-section geometry right. So that cross-section is controlled in the template editor. So this guy up here. And so here, if we wanted to create something that was new, well, we could. We could say, well, I want to use something that looks, well, maybe not a road with a curb and gutter and sidewalks. Maybe we're not paving this one, but maybe we want to have something similar to this resource low volume road. So we could copy it. We could say, well, I want to have a road width that is, well, maybe not 6 meters either side. Maybe we want to go 4 meters either side of center line. So we could come in here. We could set that. So these components in our templates act as, well, basically a fillable form. And we can pull it around, and before we kind of do anything with our center line, we can check how it's going to behave. We can check it at different stations if we'd like as well. And then, well, we can come in here and decide, well, maybe I don't want to have a U ditch. Maybe I want to have a V ditch. So I'm going to just, whoops, leave my depth at that, but I'm going to set this at a bottom width of 0, and great. And we can just copy that guy over to the other side. So pretty modular, pretty easy to work with. We could go on the eLibrary and use all sorts of other templates that have already been created that have things like walls, barriers, benching, etc. But for our case here, I think this new template that we've set up is going to be perfectly fine. And for all of these things, like what we see in terms of our view, those templates, etc., we can save them, so you only set them up once, modify them as needed, but you could save them and have it appear as your default if you save over your normal.tpl in this case. So that template that we've created, a little different. We're going to assign it. We'll go from station X to station Y. We'll see the change take place. We've assigned it to our whole road. And now that our cross-section geometry is appropriate, we are going to do that vertical optimization that we kind of introduced the concept of. So volumes are important. We want to have the template right. And then rather than trying to move things around manually, we're going to let the software figure out the best alignment that minimizes our cuts and fills and all that good stuff. So here I'm just setting my design specs. So max grade, 16%. Sags, crests, we'll go 4 and 3. We have to hit add and edit so that it gets applied to the list. We can add a control point if we want to be at a specific elevation anywhere. If we wanted to have other things like a minimum fill height, we could, but here I think we're going to be in good shape just running with the specs that we're running with. So we'll let this thing think. It's going to chug away, and it should spit out a optimized vertical alignment fairly quickly. And voila, we've got an alignment. And here I should just mention that I am running with an exaggerated vertical. So that's not crazy steep, like 120%. Here I've got it stretched by a factor of 10, and my grades are just being shown as a label. So we can kind of zoom out here. We'll look at what we're dealing with. So here we can see that, well, we've got a couple decent cuts and fills, for example, as we come up over that hump, but we're only really filling about 3,000 cubes. And other than that, we've got a solution that's balanced in the end and very close to balancing along the entire geometry. If we decided that we wanted to throw in a culvert somewhere, well, we could do that. So just right up here, and I'm happen to be right at the crest of the saddle, so I probably don't need one there, but maybe we want one a little lower. Maybe we'll throw one in here somewhere. So if we decide we want to put that culvert in, we'll go to the culverts panel, and let's, so I want to throw it right there. We'll click add. There we are. If we want to change the diameter, we can change the diameter. There we go. And well, as we're designing, we can see our volumes being reported over here. So we did about 4 kilometers of road. We're cutting and filling about 30,000 cubes. We need 3,000 cubes of gravel for our surfacing material, and away we go. So of course we could add in more culverts. Once we were happy with where we're going with it though, we could put together a documentation. So we could come over to our multi-plot editor, and we could come up here and we could add in individual subviews and build out this document from scratch. But we don't have to do it from scratch. If we'd rather just say that we have a size D sheet, well, we could go on here to the e-library and we say, well, I want to use a plan over profile that's already been set up and formatted for me. And there we are. If we want to make any changes here, well, of course we can. Let's do that. We'll change our scale of things. And then we can add in another pre-formatted chapter that is our cross-section geometry. Once we're happy with all that, well, we can print it, plot it, away we go. But if we wanted to use it again on the next project, we could hit save book layout, and that's going to save both the chapters, but also the chapters within inside the book. So the next time we can just grab that rather than reinventing the wheel. And here, just for a little context, we can go open book layout, and we'll say, well, I want to grab this chapter that's already been built. And there we are. So again, we can rinse and repeat, use something that's already been created before, and we are set. And lastly, if we wanted to take this out in a digital format, maybe we wanted to share our line work with our GIS team, or share the model for construction staking, well, we could hit File, Save As, change the extension to whatever format we'd like. So GIS, often going to be shape. Construction staking, XML is going to be a good one. Hit that, hit save, and away we go. So hopefully that covers our basis as a little bit of an introduction. And of course, we stepped through each step. But it's pretty quick, pretty easy to work with. And if we ever wanted to move something other than just using the optimized solution, we can also just grab it, move it around, and everything updates, including our volumes, slope stakes, documentation. It's all being accommodated in real time.
Awesome. Shall we move into some questions? We've got about 6 minutes left in our actual scheduled time, which for those of you new to our webinars does not happen very often. We are chronic overtimers here when it comes to webinar content. Matt, the first question. Can you optimize cost for incorporating the smallest stream crossing as well?
Yeah, so it'll depend a little bit on the lens that you want to do that. So when I ran this, I had it set so my streams all had the same cost. And with that, the stream lines themselves are just lines. Now, by default, there is some kind of behind the scenes logic in there that's going to, well, get it to trend to try to cross relatively perpendicularly, which is going to be helpful, and trend, so it's not going to be an absolute. So here we have one that's crossing fairly skewed. But yeah, so it's going to generally favor perpendicular crossings, provided that's going to be the way it sees the cheapest solution. Now, beyond that, if we wanted to favor smaller stream crossings in the sense of, well, I want to have my streams that have a drainage area of 150,000 square meters contributing to them, they're going to be bigger streams and cost more. Well, we could run that streams tool and have kind of different tiers of it. So maybe your big streams versus little streams, and we could just kind of automate how they're categorized that way. And we could make the bigger streams cost more, and then it's going to favor crossing the smaller streams. I suspect that's not really what the question asker is looking for. It's more, well, if I have a river or something like that, can I choose it where the stream is pinched off? And in that case, you can. And there's a few different ways we can tackle that as well. So one could be that we manually choose the location of our crossing. So maybe I just come down here and I say that I want this to be my bridge site. So I'm going to make a new feature. We're going to go from, well, one abutment to, and actually watch me choose a bad spot for it. We'll go over here. One abutment to one abutment. And well, if we wanted to still have that start point to end point set up, we could add in another kind of waypoint. We're not actually choosing the we're letting the software choose the crossing location. We say that that's the bridge. We need to go through it. And if we want to control it so it, well, approaches from one direction and leaves at another direction, we can tag that endpoint in as being a tangent. And then it's going to go through that particular spot. And then the other aspect of it is if you're trying to choose a bridge location and you happen to have streams that are polygonized instead of just these lines as kind of the center line of the stream, well, you could add that in. And then instead of using a crossing cost, you'd have a polygon cost. And well, the narrower streams are going to have less of a cost to deal with it. So you can go that way with it. So hopefully between the different explanations there, hopefully that does answer the question for the question asker. The gist is though, there's lots of flexibility and you can really use different tools in the software and strategies in the software to get a desirable outcome.
Awesome. Matt, our question asker, actually replied, said that answered it. So that
Cool.
is fantastic. And our audience, who was previously not asking questions, has woken up, and I love it. There's some fantastic questions in here. Okay, the next question on our list. What's the workflow to design access roads to multiple locations while optimizing the entire road network? Not only point A to B. And I feel, actually, I'm not too familiar with this person. I should say, coming out tomorrow, a brand new beta, and we're running version 12. You've heard us talk about it. We have been introducing new betas for 12 for the past, 6 months, I think so, as we beta test new features and functionalities. And tomorrow marks a very special day. It is Path Explorer Beta Network Day. So if you are part of our support clientele, you can contact us, get access to the beta, and what Matt's going to show you can be in your hands as of tomorrow. Very exciting day. Matt, I'll stop talking and let you do the showing.
Yeah, let's see here. Oh, and what did I do? Okay, we've got that. Oh, I just need to set it on my surface. All right, so this is going to be, I guess, quite simplistic, but if we want to go from that start point, we want to go to that end point, but we also want to go to that end point. And we don't care that it's along the same route. So not necessarily the same thing as that bridge example where we connect them in sequence. We could come over here. We could set this guy up. So start point, end point. I think I made one that's just called C. Now I'm going to say, well, this is still my start point. So the start point matters. The end points don't. So it's going to go from one to the other. We're going to use the same design criteria for all of them, same costs for our construction zones. We'll hit OK. And we'll let this run. And we'll see that it'll give us a network rather than, oh, actually, I did this earlier too. I don't want it to connect in sequence. Most important thing. For networks, we're going to change it to be a network problem. These also get quite cluttered if we're producing a bunch of different options. So we're going to just report one possible configuration, but start point, end point, and yeah, tag it in as being a network. So we'll hit OK this time, and now it's going to do its thing, and we'll let it go. And yeah, just arbitrarily drew something in there. I don't think it's going to take too long, but yeah, it'll take a little longer than that last run. So we probably have, I don't know, 2 minutes here to let it think, and we'll yeah, see what it spits out. And while that thinks, there is a boatload of questions over there, so maybe we can
Yeah,
answer
let's
one in the yeah.
pivot to one in the location module. That way you can demonstrate an answer if we need. This one's, I think, a pretty easy question for you, Matt. How can I share the cross-section template I'm using with a colleague? Or do they need to
Yeah.
set it up themselves?
Oh, so we can just hit Save Table. And we can save it as, well, whatever we like. And if we saved it normal.tpl in that default file location, that's going to be your default cross sections the next time you start, or the default library that it has to pull from. But you can just save this normal.tpl anywhere and share it with your colleague, and your colleague could come over here, they could click open, and they could navigate to wherever you've saved that other file, and that's going to replace everything in their list. Now, if you had clicked merge, and I'm just going to grab something random, we could click merge, and that adds to our list here. So rather than replacing everything in here, I get to choose which templates I'm actually going to add in. And there we are. We've got our ditch template in this case, and I think it is just a single component. But yeah, add it in instead of replacing everything. So very easy to do.
Okay, if we have time for another question, Matt, I'm going to keep you
Yeah.
inside the location
Yeah.
module. And I completely agree with this particular question because we move so fast in webinars, which, maybe a good moment before I ask this question out loud, a good reminder, we do cover stuff fast in these webinars. They are posted afterwards to our YouTube channel. You can pause it, you can slow it down, you can fast forward it to the sections you want. So yeah, please leverage that link you get after the recording is finished, and we'll email it out. So this question, can you briefly re-explain how to use the vertical optimization tool? It went over my head. And yes, I feel you, question asker, on this one, because yeah, we do move with speed.
All right. So let's just, I'm going to delete my vertical alignment here just so we can kind of have a fresh perspective on things. So when we ran the vertical optimization, we come over to our vertical optimization dialog, and we can get there a couple different ways. So I'm a right clicker, so I go to the Project Explorer panel and I right click in here. But we could very easily just come up to the top here and click, well, I want to set up my vertical options. So what we have here is we're saying that the software can put the road anywhere within 10 meters of our center, which in this case is ground. And well, it's going to look at the cuts and fills along the geometry. So we've got our cross-section template already assigned, but it's going to look at, well, what we have provided for a max and min grade, and it's going to look at the curvature that we have specified. So, and then it's going to try to minimize the cut and fill cost, but also our haul cost to produce a vertical alignment that, well, minimizes earthworks costs through material movement, excavation, and fill. So at the bare bones, that's the gist of it. We're just letting the software use a bunch of fancy math to calculate the solution that minimizes our costs. Beyond that, there's all sorts of little nuances that we may want to account for that kind of lets us add realism aside of just looking at it at what's the cheapest geometry given what we've provided it. So each one of these tabs kind of feeds into that, well, capturing realism. So standards, well, that's max grades, control points, I want to be at this elevation at this particular spot. So a big thing here will be, well, we've got our maybe a bridge abutment. So the software is going to look to minimize our earthworks. It's not going to look to, say, have an adequate clearance over a bridge. So we may want to add in a particular location where our abutment is set at a certain elevation. So we can add that in with control points. Now, pits would be, well, of course, the cheapest solution is often going to be a balanced solution. But sometimes not every project makes sense to balance. So if you had a section where you were maybe overlanding, so a fill-only embankment, well, you're not going to mine the ditch to get your fill material there. We could add in a pit, and we could say that borrow pit's going to be allowed to develop material out of it, so we have somewhere that our fill material, well, it has to be cut at some point. So we tell us that the pits could be mined for material. Unit costs. So as the software looks at minimizing those cuts and fills, it's looking at, well, minimizing the costs that we provide. So we've got an overburden cost, and I said it's $12 a cubic meter to cut, $4 a cubic meter to take that excavated material and shape it. We've got our haul cost in here. So it's going to cost money if we have to move material a long ways. So that cost is, well, there's a loading cost and a hauling cost associated with that. And if we had, say, solid rock, it's going to cost more to excavate it than if it's just some material that we can dig with the bucket. Again, another kind of level of detail for, well, capturing the reality. And we use that overland example like a fill-only embankment. Well, we could add a minimum fill height from station X to station Y, or we could add in a full bench constraint if we're building across the site of a steep mountain. We can add in all this stuff, and then we can click process. We can let this guy go, and it's going to, again, solve that cheapest solution to get our alignment up to the top of the hill. So hopefully, yeah, slowed down a little bit there, but yeah, it's just generating a vertical alignment for the project that minimizes the earthworks that we're dealing with.
Okay. And when that's done, we'll pivot back to the question about Path Explorer networks. Again, we're solving pretty large problems here, and we're doing them live in a webinar, which means that they take more than, the quick click of a button. There's usually a processing time, 1 to 5 minutes, maybe more, obviously, as it scales up, depending on the number of sites you're looking to visit in a network. And Matt, looks like you've
So
got some results.
there's our network. So the main road goes the longest distance, but we have that spur coming off that is, well, going to where we'd like to be. And yeah, if we were to compare the previous solution to this solution, we'd find that this yellow solution is kind of nudged over to favor getting closer to that than rather just going directly here and adding a stub off the side. So it's yeah, it's a pretty fast, slick tool. And yeah, I suspect, oh, that probably took 2 minutes or so. I didn't catch when it actually chimed, but yeah, pretty slick. Yeah.
Oh, I have to unmute to be able to talk. Sorry
Okay.
about that. There's another question, actually. I believe it was tied in to that last one, but interestingly asked by a different question asker. Is there a limit on the number of points I can set? And I believe
Oh,
they're referring to networks, but I'm not totally sure. Question asker,
okay.
please clarify in the chat if it's different.
Yeah. And I guess while we wait for their response, assuming it's networks, we have something hard coded currently that's probably going to be increased, and with that, the problem size scales up quite a bit. So I wouldn't really feel comfortable giving an absolute number in terms of yeah, something to use as a rule of thumb. The ceiling's quite large. Context, last week I ran an example with, I think, 40-ish destinations, and it solved very quick, like yeah, extremely quick. at some point, for a practical answer, it'll be kind of scaling up in terms of the size of the surface that you're dealing with. Will probably be just as limiting as anything else. So yeah, it can solve pretty large problems very quickly, and at least speaking from my own perspective, it can solve them way better than I can too. So
Awesome. Sounds like we did answer that one correctly from the chat here. So let's go with one last question and then we'll wrap up for today. And thank you guys for being an engaged audience in the end. I was a little bit worried about you. The last question, can you adjust the road prism to account for overland sections versus balanced sections? And if
ah,
so, how do you account for the distance from borrow locations? This is a long
okay,
question. I'm going to keep going for a second.
okay,
For example, it appears that the lower portion of your road crosses a low-lying floodplain, which may have been overlanded using ballast. May have to be, sorry, which may have to be overlanded using ballast. Using a balanced road through that section could underestimate the costs. Can you account for this?
yeah. Let's see here.
And it's a great question, by the way.
So let's just back up a little bit here. Um, so this particular site that we're looking at, we've got, well, we're kind of hitting these nubs. It's not super flat. It's terraced across that, and then we're down into the floodplain. We have our crossing here. So yeah, I suspect this one's not too bad, at least not as bad as it would look if we're just looking at the ortho. And to me, it looks like that swamp. But yeah, it's. I don't think it is when we look at the 3D. But if that was just say a really flat area, and we wanted to have an embankment set, we could. And well, we go up, well, one for our cross-section geometry. We can have that set, and it's using the same geometry as we go. Now, with this, I've got my subgrade. We could say that that subgrade material for a certain location had to be made out of a certain material. So if we wanted to get real fancy with it, we could say, well, our fill material from station X to station Y had to be gravel. So we could account for that realism, so we aren't just using the material that's close by. The next thing that we could do would be, well, we could come in here, and well, we could, of course, design the road yeah, however we want. We could lift it, or we could say the software, I want to be from, well, a meter embankment height going from station 800 to 950. And so, well, then instead of having our grade down on our flat here, we could bump that up. And we could say, well, in that constraints tab, minimum fill height, we're going to make a meter embankment minimum. And we could say, well, let's go 850 to 950. And then that minimum embankment would be accounted for. And then lastly, if we wanted to have, well, where's that material going to come from? And if we left that as is in this case, it's probably going to just drop the grade on the approach and develop the material needed to bump that up. But if we wanted to account for, well, that has to be that gravel material that we said it needs to be, and we want it to have a pit here or anywhere along our project, we could go to the pits. We could say we've got that pit. We could add it at the station, I don't know, 600. We could say that the material is, well, a borosite. We could say that the material is that gravel source, and away we go. And then the software is going to account for the, well, where that material comes from and goes to. And then if we really wanted to go down the rabbit hole here, we could add even another constraint where we say that if we're building across, and this again, I don't think it's that soft, not as soft as it looks like just based off the ortho. If we had a real swamp where we couldn't just pioneer ahead, well, we could even get into the material direction constraints and say that, well, in order to build that overlanding section, we're going to end dump. So it's going to be forward material movement only from station 800 to 950, whatever we wanted to assign there, and away we go. And we could rerun it. And that's kind of the lens that the software is going to look as it does its optimization. So it's pretty smart. You can throw a lot at it, and it's going to gobble up whatever you throw at it and solve the solution based off the way you frame the solution. But yeah, so it's absolutely capable of it. It would take another minute there to rerun, and we'd get the solution, and it would be optimal provided all the constraints that we've added, and these do act as constraints. So hopefully that answers your question.
Awesome. Okay, team. Thank you so much for joining us for today's introductory webinar on RoadEng for resource design. We started pretty easy. We got into some fun, complicated questions here at the end. As a reminder, we're happy to answer any additional questions that you have after the fact. Please feel free to reply to the email that comes out with the video link. We're happy to tackle them. And with that, thank you, Matt. Hope everyone has an awesome rest of your day. We'll see you at the next webinar in a few weeks.
Cool. Thanks, everyone.